Hello, welcome to our third lesson on reading and writing engineering research articles. In this lesson, we'll be looking at the argument structure of research articles, particularly the claims and component claims that we find in the articles in different parts. So in the last lesson, we looked at how IMRD and IPTC differ in terms of the section number, the section names, and the longest division. But far more important is why they differ from one another. Well, we'll find that they have different goals, and as a result of these different goals, they have different argument structure. And that different argument structure is predictable, and that makes it easy to find the information that you need on a particular topic. So the goal of this lesson is to read through your article and find the main components in each section. And this again is based on the textbook, Chapter 3. So when I'm talking about arguments, I'm not talking about a fight. I'm talking about a logical argument. A logical argument is one that's based on making a claim and then supporting it with evidence and reasoning. Now, all science and engineering writing should be written as logical arguments. It's not just a report of what was done, but making a claim and supporting that claim several times throughout the article. So let's look more carefully at this idea of claim and evidence and reasoning. If I want to make a claim, I want to claim something that I believe is true. For instance, I could say that leaves are usually green. Well, how would I support this claim? First, I would look for evidence. I would observe many different leaves, and I'd find a lot of leaves are green, but not all. And so then I would support my claim with reasoning. I would say a few or other colors, particularly when a leaf is young, it may be red or some other color, but most of the time leaves are green. And so I make a claim supported by evidence and reasoning. Every research article in general makes 3 implicit claims. Now, notice I say implicit. These are not stated directly anywhere in the article, but they guide the overall structure of the article. Okay, so in science, the first implicit claim is that you have an important unanswered question. The second is that you've gathered your data in a valid and reliable way. The third is that you have a good explanation for that data. In engineering, it's a little different. Engineering begins with an important unresolved problem. And then it makes the claim that you have designed a workable solution for that problem, followed by the claim that your solution is better in some way than the existing solutions. Now, this is shown in the structure of the research articles. Each of these main implicit claims represents one division of the research article. So, in the introduction of a science article, that's where you make the claim that you have an important unanswered question. Then the methods division makes and supports the claim that you have gathered the data in a reliable way. It's not just a list of what you did, it's showing that you did it in a valid way. And then the results and discussion, the results show the data, and the discussion shows the explanation for that data, supporting the claim that you have a good explanation for it. On the other hand, in engineering, you begin in the introduction with an important unresolved problem. And then you make the claim in the process division that you have a workable solution. And so you have to present all the details that show your solution works. And then in the testing division, you show that your solution is better than the existing solutions. Now, you could also look at this in terms of the article structure, that in science, the introduction talks about the question to be addressed by the data. The method then talks about how the data were generated. In the results, you talk about the summary of the data. And finally, in the discussion, the explanation of the data. And so in that, you see the focus is on the data. And that's why the focus of an IMRD article is on the results and this discussion. On the other hand, in engineering, the introduction talks about the problem that you're going to solve by the design. Process talks about the solution proposed by the design. Testing, the comparison with the previous design. And then the conclusion, the advantage of the design. And so again, you can see that the structure of the article supports the design, and because the design is presented in the process division, that becomes the most important part of an engineering article, and the longest. So again, this answers the question that we asked at the beginning. Why are science and engineering so different? Because again, science begins by asking questions and then develops explanations based on the data. And so the longest division is the results division, where the data are presented. On the other hand, engineering defines problems and then designs superior solutions. And so the longest division is the process division that shows the design. Okay, now let's move on to the idea of component claims. Now, notice that I say that these are component claims. Component means part of something. And so these are part of those 3 basic claims. But there are 10 of them. And again, these are common in most research articles in most fields, but they're not always found in exactly the same place, even though they seem to occur in the same basic order in many cases. Okay, so in IMRD, the first 4 of those components are frequently found in the introduction: importance, need, research goal, and framework. Now again, these are just names, but how are they related to claims? Well, the claims are going to be different depending on the particular research, but in general, let me give you some examples of what those claims might look like. Importance might say that this question is important to either society or the field, or both. Need, that a gap exists in our current understanding of this topic. The research goal then says how we are going to answer that question in this article. Now, the framework is a little bit harder for many people to find, especially when they're first beginning to do research. But the framework talks about an existing model or a framework, things that other people have done that we are building our research on. In the next division, the methods division, it says that we have gathered the data in a valid and reliable way. And for this, there are 2 components: the research details and testing methods. Now, the claims associated with those, the research details, is not just a list of details. It shows that the researchers took proper care to ensure that the results were good. And the testing methods says that certain predictions were made based on the model, and either those were proven true or proven false. Then in the results and discussion, you find the data patterns, the comparisons, and the interpretations. And the conclusion, obviously, in the conclusion. The claims, the data pattern says that a pattern can be discerned in the data. It's not just the data itself. Comparisons compare your current data either with previous work, saying how it supports or questions previous work, or within the paper. And then the interpretation claims that the data are best interpreted in a certain way. And the conclusion goes back to your research goal and says that that question that you proposed has been answered. This is summarized in this single page that shows the location of the claims and the subclaims, the component claims that are usually associated with them in science, in IMRD. Now, in IPTC, you have the same 10 component claims, and usually in the same order, but the division structure is a little bit different because of the difference of the implicit claims. And so we see that framework usually shifts to the beginning of the process division, whereas testing methods usually shifts into the testing division. Let's see why. Okay. In IPTC, the first claim is that you have an important unresolved problem. And so it looks at the importance, that this problem is important to society and the field. the need that the current best solution is limited or less than ideal, and the research goal that you propose a better solution in this article. Then, in the process division, the process begins with the framework that claims that this is the best approach to use in this research, because my research is built on this, and so the two are very closely connected. And then that a workable solution was designed. When we move to the testing division, we find the testing methods, because the testing followed a verifiable standard procedure, and that's immediately followed by the pattern that can be discerned in the data, and showing a comparison that the design performs better than previous solutions. Interpretation may or may not be present in engineering, but if it is present, it will show that the designs either conform to or differ from the expectations. And finally, that the solution is an improvement on the current best, again referring back to the research goal. So you may wonder, where are my TAs? They haven't been here. I guarantee they will appear in the second video, so take a look at that.